In this video, I'd like to go over something I call algebra with shapes. So, algebra with shapes. Okay? And I'm going to be using the following shapes and colors to do this algebra. And the base equation that we're going to start with is blue circle equals green diamond divided by red square. And so I do this with students because I find that when I say and do things in terms of a blue circle, a green diamond, a red square, or any basic shape, it's a lot easier to understand and follow than if I were to say, do an equation such as A equals V sub f minus V sub I divided by delta t. And I say, now solve for delta t. And students look at that and it could be a very intimidating thing. But if I just say blue circle equals green diamond over red square, and I say solve for the red square, it looks a little bit less daunting. And so we're going to come back actually to that acceleration equation later, but that would be in another video. Let's just start with this basic algebra with shapes equation. And what we're going to do is we're going to try to solve for the green diamond, and we're going to try to solve also for the red square in this equation. Now there's two principles that you've learned in algebra and that we want to review here. The first principle is that anything done on one side of the equation must be done on the other side. And so when I say anything, I literally mean if I'm going to add on one side of the equation here, then I'm going to have to add on the other side of the equation here. If I'm adding 4 here, I'm going to have to add 4 here. If I'm multiplying on one side, I got to multiply on the other. So anything done on one side must be done on the other. And that's true because we have this equal sign right here in the middle. And to keep things equal, you have to make sure that you perform the same operations on each side. The second principle is to cancel or remove an entity from one side of the equation, perform the opposite operation with that entity. The opposite, okay? And so we know the opposite of division is multiplication. We know the opposite of addition is subtraction. And so if you want to remove an entity, when I say entity, I mean a shape, a number, a variable, anything like that. You want to get rid of it on one side, then you're going to have to just do the opposite operation. All right? So those are the two things we're going to be utilizing. I'll focus on this as our base equation. Blue circle equals green diamond divided by red square. And we'll just keep that boxed. And what we want to do first is we want to try to solve for green diamond. All right? So what does green diamond equal? Well, first let's write down our base equation. Blue circle equals green diamond divided by red square, divided by red square. Okay? We got to get this green diamond by itself, and we see what's being done to it is it's being divided by the red square. So using our second principle, we're going to do the opposite of division, which is multiplication. So I have a purple multiplication symbol there. And we're going to multiply by the same thing that's being done to it. So it's being divided by a red square. I'm going to multiply by that red square. And then I'm going to use the first principle. If I'm doing anything on one side, I got to do it to the other. So I multiplied by the red square on the right side of the equation here. Now I'm multiplying by the red square on the left side of the equation. When I do that, you can see that anything divided by itself is 1. So I could cancel that out. And if you look, the green diamond is by itself now, which is exactly what I wanted to do. And so you end up with red square times blue circle. Whoops, that's indigo. Let me change that. Times blue circle. Doggone it. Hold on. Blue circle equals green diamond. Okay? And we're done. And so I can rewrite this as green diamond. I'll just flip this whole thing down here. Green diamond equals red square times blue circle. Students are like, well, it says can I flip this? Can I say green diamond equals blue circle times red square? Absolutely. We know multiplication is associative, and so if I wanted to, I could also say green diamond equals blue circle times red square. Same thing, okay? And so this is now our second equation that we've derived, or second equation, the first one we've derived, but we have our base equation here, and then we have this one. Now with this base equation, we want to solve for the red square. Okay, so let me erase what we have down here. And now we want to solve for the red square. Okay, so we want to say red square equals what? Okay, well, what does red square equal? So let's start with our base equation again. Blue circle equals green diamond divided by red square. All right. Now what's interesting about this problem that we have, if we want to solve for the red circle, the first thing we have to do is get this red square, excuse me. If we want this red square, we have to put it into the numerator. And so what we want to do is we want to get it into the numerator. It's in the denominator now. So the first thing we're going to do is actually multiply by the red square to get it into the numerator. Do it to one side, got to do it to the other. Okay? Anything divided by itself cancels, you're left with that equation. And what you notice here in this equation is that the red square times the blue circle equals the green diamond. This is the equation that we just came up with, isn't it? Right up here. But we're going to use this because now we have the red square in the quote numerator. There's no fraction here, but if you divide this by 1, it's the numerator. Excuse me. And now we want to get it by itself. So what's being done to the red squares? It's being multiplied here. It's an understood multiplication by the blue circle. So we have to do the opposite. We're going to divide by that blue circle. You do it to one side, though. You got to do it to the other side. Divided by the blue circle. And as we know, anything divided by itself cancels, right? And so we're left with the equation red square equals green diamond divided by blue circle. And that equation's done. Hooray. Okay. So now we can write it in up here. Green diamond divided by blue circle. And that is our third equation, the second one we derived. If you can do this, if you can take this base equation, equation 1, and then derive from it this equation 2 and this equation 3, then you should be set for any algebraic problem, formula that I'm going to ask you to manipulate. For example, let's say I ask you to take this equation, A equals d sub f minus v sub I divided by delta t, or acceleration equals final velocity minus initial velocity divided by the change in time. And I say to you, I want you to solve for delta t. Well, most students look at this and they're like, what the heck? What am I supposed to do with this? How do I solve that? That looks too intimidating or daunting. But all it really is the A is the blue circle, the v sub f minus v sub I is the green diamond, and the delta t is the red square. And so you can perform these operations, get the green diamond first, and then get the red square in the numerator, and then work it out. And from it, you can solve it. And if you want to practice it, the final answer for this is delta t is going to equal v sub f minus v sub I all over A. All right? And so, in essence, what I've done was I've said red square is equal to the green diamond divided by the blue circle. But shapes are a lot easier to kind of get started with than all those crazy variables. So I hope this was helpful. Email me with any questions, and we'll stop here.